Today's lesson is 1.5 linear equations. The objective for today is to solve linear equations and quadratic equations. So the first definition we're going to do is a linear equation, which is an equation with the form of ax plus b equals 0. And then if you can see that little note on the side, it says it's a first degree equation, which means that x only appears in the first degree. So it never shows up as x squared or x to the third or x to the negative 1, anything like that. It only shows up as x. A and b are real numbers and x is a variable. Okay, so a couple of examples of this are down here. A few linear equation examples are 4x minus 5 equals 3. You'll see that the x shows up only in the first degree, and you can move everything to one side to make it look like that ax plus b equals 0 that you're looking for. Okay? Same thing with 2x equals 1/2 x minus 7. Even though there's a fraction there, the x is still in the first degree. And then x minus 6 equals x over 3. So even though that's still a fraction, that also has a fraction in it, x is on top, which means x is still in the first degree there. Okay? But some non-linear equations, so some non-examples, are like x squared plus 2x equals 8. That has an x squared in it. Okay? The square root of x minus 6x equals 0, that's another non-example because it has x to the 1/2. So the square root of x is the same thing as x to the 1/2, so that's not to the first power. And the last one is 3 over x minus 2x equals 1. And this one, since the x is in the denominator, that makes it the same as x to the negative 1, and that is not a first degree equation, so that is not going to be linear. So here are two examples where we will solve for one variable in terms of others, and these are linear equations, so solving for those. Okay, so the first example, example 2, solve for the variable capital M in the equation f equals capital G times lowercase m times capital M over r squared. So the first thing we just want to do is get that capital M on its own. So I'm going to rewrite the equation with m, the capital M's kind of by itself. Which this is the same thing because it's the fraction multiplied by m, and then that would just go back on top just like it was here. Okay, so now we have the m sort of by itself. So now we have this fraction here that we can flip and multiply on this side. Okay, so let me show you. If I multiply by r squared over g lowercase m, then actually the r squareds cancel, the g's cancel, and the m cancels. That leaves that m by itself. I'm going to do the same thing over here. R squared g over lowercase m. So my answer is going to be m equals r squared g over m times f, and actually we'll just put the m first. We'll just switch everything around. I'll put the f here, and then r squared g m, and that's my answer. Okay, and then example 3, the surface area of the rectangle box that can be calculated from the formula. A equals 2LW plus 2WH plus 2LH, and I'll rewrite that formula if you can't see it. I know the lighting is bad. So we need to solve for W in terms of the other variables. So in this case, we want W to be by itself. So I'm going to rewrite the equation. Okay, and we want the W by itself, so we're going to leave everything on that side, on the right side, that has W, and we're going to move everything else to the left. Okay, so the thing that does not have W is 2LH, so I'm going to move it over here. So I'm going to get A minus 2LH equals 2LW plus 2WH. And so now we can pull that w out as if it's a greatest common factor. We can only do that because there's only stuff with w's on this side now. Okay, so I'm going to leave this the same. And then on this side, I'm going to pull out the w, and we'll still have 2L and 2H on the inside. And now we can, it's w times that whole thing. So to get w on its own, we can divide by that whole thing. Okay, and that cancels top and bottom, and we need to do the same thing on the other side. Okay, and so now we're going to get w equals a minus 2LH over 2L plus 2H. That's the answer there. Okay, we can do some more notes now. Time to give the definition of a quadratic equation, which is an equation in the form of ax squared plus bx plus c equals 0. And then if you'll see my note over here, this is a second degree equation, so it has to have an x squared as the highest degree. Okay, so a, b, and c are real numbers, and a is not equal to 0. So some examples of quadratic are 2x squared equals 4x plus 3. So you know that you can move all of that stuff to one side, and you'll get it in the same form as above. And then another quadratic is x squared equals 9. So here, there's only an x squared, so that's an a value, ax squared, and then a 9, so that's the c value. There's no bx, but that's okay because all we need is the x squared. Okay, and then there are different ways to solve quadratic equations. The first way is factoring, which we'll do some examples of that. You can also solve a simple quadratic, which means, here's your notes for that, if the quadratic looks like x squared equals c, then you can solve it by just saying x equals the square root of c, or x equals the negative square root of c, which is pretty straightforward. And the last way to solve quadratic equations, if you can just write it down below, down here, but I had to put it on the next board because it was a little bit longer. The last way to solve quadratic equations that we're going to go over today is completing the square. So basically this is how it goes. To make x squared plus bx a perfect square, you need to add b over 2 squared, and this gives the perfect square of x squared plus bx plus b over 2 equals parentheses. Let me make sure the light works. There we go. Okay, when you add b over 2 squared to the end here, it actually makes this whole side into the perfect square that looks like this, x plus b over 2, all of that squared. Okay, so we are going to have to practice that, and maybe some of you have seen it before, but we'll do some examples today. Okay, so here are two examples. The example 4 is factoring, which you probably know how to do. You might need a refresher. And number 5 is a simple quadratic. So we need to find the real solutions of x squared plus 5x equals 24 by factoring. So the first thing I'm going to do is get everything on the same side. So I'm going to subtract that 24 to both sides. I'm going to get 0 over there. And then now I can factor it. You guys maybe remember a t-chart. Okay, so this is A, B, C. It's in order. So your t-chart is A times C, which is 1 times negative 24. Make sure you can see that. Okay, and then B over here is positive 5. So you need to pick two numbers that multiply to negative 24 and add up to positive 5. Pause the video and try it for yourself. You should get 8 times negative 3, or 8 minus 3, or plus negative 3 is going to give you 5. Okay, so now we know our two answers here, and since this is, there's nothing in front here, we can actually just immediately write it in factored form like that. So we're going to get our x's, we're going to get our positive 8 and our negative 3 are our two factors, and then we're just going to solve for each of those. Okay, so x plus 8 could be 0 to make this answer 0, or x minus 3 could be 0 to make the answer 0. So I'm going to get x equals negative 8, and x equals positive 3. And those are my two answers there. Okay. The next example is example 5, a simple quadratic. Find all real solutions for x squared equals 5 and x minus 4 squared equals 5. Okay, so the first one is pretty straightforward based on your notes. You can just take the square root of both sides. Okay, so that cancels there. The squared and the square root cancel. So you get x equals the positive square root of 5 and x equals the negative square root of 5. Okay. You could also write it as x equals positive or negative square root of 5 if you would like to, but it's helpful to write it as two different answers so that you know it's two different answers. Okay. Okay, and then b is actually, if you think about it, pretend this whole thing is like an x squared equals 5, so you can actually do the same thing. This whole thing is squared, so you can actually square root the whole thing and that goes away. Okay, and you get the same thing on the other side, so you get x minus 4 can either be positive square root of 5 or x minus 4 is negative square root of 5, and then you just solve those two. Okay, so x, you add 4 here, and you get x equals 4 plus the square root of 5, and then you add 4 here, and you get x equals 4 minus the square root of 5. Okay, so those are our two answers. You could also, again, write this as x equals 4 plus or minus the square root of 5 if you wanted to. But you need to make sure you get both answers in there, or you only get half of the answer and half of the points. Okay. So now we have some completing the square problems. Example 6 says find all the real solutions of the equations here. X squared minus 8x plus 13 equals 0, and 3x squared minus 12x plus 6 equals 0. So we need to complete the squares to figure this out. So remember to get your complete the square notes out and to try and follow along. So first on A, we need to get the x squared and the x alone on that side. So I'm going to subtract the 13, and I'm going to get x squared minus 8x equals negative 13. And then I'm just going to make some notes on the side. The first thing I need to note is what b over 2 is. Okay, so b over 2 is this value right here, negative 8 over 2. So I'm going to put negative 4. I just need to keep that in my head. And then I also need to figure out what b over 2 squared is. So I'm going to do a second line here for b over 2 squared, and that's going to be negative 8 over 2 squared, which is negative 4 squared, which makes it positive 16. Okay? And remember, we need to add that b over 2 squared to both sides. So we need to add 16 to both sides. Okay, and then it says that once you do that, you can actually rewrite this side as x. So let me rewrite the equation we had for completing the square. X squared plus bx plus b over 2 squared, which we have over here, is the same thing as x plus b over 2 squared. Okay, so I'm going to rewrite it as that. I'm going to rewrite it as x plus b over 2 squared. So that's going to be x, and then b over 2 is negative 4, so x minus 4 squared, and then this side just simplifies to 3. And now this looks like something we can solve. Okay, we can take the square root of both sides. We get x minus 4 equals the square root of 3, and x minus 4 equals the negative square root of 3. So then we solve it. We get x equals 4 plus the square root of 3, and x equals 4 minus the square root of 3. And those are our two answers there. Okay. And then I'm going to do b over here because there's not any more room there. So for b, we've got 3x squared minus 12x plus 6 equals 0. So in the same way, I'm going to get that 6 by itself. I'm going to get the x squared and the x by themselves. So 3x squared minus 12x equals negative 6. Okay, and in order to do the completing the squares, we actually need this x squared to have nothing in front of it. So we actually need to divide everything by 3. On this side. Or we need to pull the 3 out and then divide everything by 3 to get rid of it. Okay? Whatever you do to one side, you have to do to the other side. So now we're at x squared minus 4x equals negative 2. And now we're in a position to start working on completing the square. So I'm going to take some notes over here. I need b over 2. My b is negative 4. So b over 2 is negative 4 over 2, which is negative 2. Okay, my b over 2 squared is negative 4 over 2 squared, which is negative 2 squared, which becomes positive 4. Okay, so I'm going to go write that in here. So I have, I'm going to add 4 to both sides. So x squared minus 4x plus 4 equals negative 2 plus 4. And then I need to write this in the new form. Remember the form is x plus b over 2, which is negative 2, squared equals 2. It simplifies to 2 on this side. And then we can just start solving it from there. So we can take the square root of both sides. We get x minus 2 equals square root of 2. And x minus 2 equals negative square root of 2. So we get x equals 2 plus square root of 2, or x equals 2 minus square root of 2. And that's how you complete the square.